Response spectrum analysis for regular multistory structure in seismic zone 3. Abstract and RCC framed structure is basically an assembly of slabs, beams, columns, and foundation interconnected to each other as a unit. The load transfer, in such a structure takes place from the slabs to the beams, from the beams to the columns and then to the lower columns and finally to the foundation which in turn transfers it to the soil. The results of analysis are used to verify the structure. Fitness for use. Computer softwares are also being used for the calculation of forces, bending moment, stress, strain and deformation or deflection for a complex structural system. The principal objective of this project is the comparative study on analysis results of multistoried commercial building, G+15, by STAADPRO and ETABS.STAADPRO is one of the leading softwares for the design of structures. In this project we had analyzed the G+15 building through response spectrum analysis to develop the economic design. ETABS is also leading design software in present days used by many structural designers. Here I have also analyzed the same structure using ETABS software for the design.is. 1893, part I, for seismic design is utilized to perform the dynamic analysis. The results were observed that the multistoried buildings are stiff for earthquake excitation as modal participation factor is found to be more than 75%. Keywords STAADPRO, ETABS, Response Spectrum Analysis. Introduction. Earthquake causes the random ground motions in all directions, radiating from the epicenter. These ground motions causes structure to vibrate and induces inertia forces in them. For the structure to perform better during the earthquakes, it must be analyzed and designed as per the Indian Seismic Code is 1893, Part 1, 2002. In the past, several major earthquakes have exposed the shortcomings in buildings, which had caused them to damage or collapse. It has been found that regular-shaped buildings perform better during earthquakes. Earthquakes causes ground to vibrate and structures supported on ground are subjected to this motion. Thus the dynamic loading on the structure during an earthquake is not an external loading, but due to motion of support. The building can be designed to resist earthquake with certain amount of damage, but without causing the collapse and affecting the livelihood. The response spectrum represents an interaction between ground acceleration and the structural system, by envelope of several different ground motion records. For the purpose of the seismic. D.S. Yerudkar 22 Associate Professor, Department of Civil Engineering, JSBM's Rajarshi Shahu College of Engineering Tathawade, Pun 411033, India. Analysis. The design spectrum given in Figure 2 of is 1893, Part 1 2002 is used. Response spectrum analysis of the building model is performed using STAADPRO and ETABS. The lateral loads generated by STAADPRO correspond to the seismic zone 3 and 5% damp response spectrum given in is 1893, PART 1 2002. A. Objectives of the present study. 1. To determine dynamic response of multi-story building for earthquake load. 2. To study story displacement, story shear, story drift using response spectrum analysis for a regular multistory building. 3. To study response spectrum analysis of regular multistory building using computer programs, STAADPRO ETABS. Response spectrum analysis. The response spectrum method, RSM, was introduced in 1932 in the doctoral dissertation of Maurice Anthony Byatt at Caltech. It is an approach to finding earthquake response of structures using waves in vibration mode. Shapes. The concept of the response spectrum was applied in design requirements in the mid-20th century in building codes of various countries. The computational advantages in using the response spectrum method of seismic analysis are the prediction of displacements and member forces in structural systems. The method involves the calculation of only the maximum values of the displacements and member forces in each mode using smooth design spectra that. See necessity of seismic zoning in India. Seismic zonation is a process, which provided information about any decision-making for urban regional planning or for earthquake design in earthquake areas. In principle, seismic zoning map is the main source of zoning, which is displaying quantities related to the expected frequency and intensity of shaking caused by earthquakes. The task of seismic zoning is multidisciplinary and involves the best of inputs from geologists, geotechnical, seismologists, earthquake and structural engineers. The rapid urbanization due to population outburst, coming up of megacities and potential seismic zones is the main reason of the seismic hazard in India. Problem statement. Reinforced concrete moment resisting frame building of different story heights are considered. The bottom story height is kept 3 m and a typical height of 3 m is kept for the entire story in the building. The aim of the study is to find the difference of base reactions, modal participation factors and periods and frequencies using ETABS and STAADPRO. Table number 2. Detailed data of building studied. A typical G+15 story plan. For modeling and analysis, the ETABS and STAADPRO software is used for modeling as well as analysis of the structure. The symmetrical plan of reinforced concrete structure having 15 story is considered. First, the earthquake loads as per is 1893-2002, Part 1 are applied for structure located in Zone 3. And dynamic analyses, i.e. response spectrum method, is carried out for 5% damping and scale factor considered as per is code in both x and y directions. Assuming that material property is linear static and response spectrum analysis is performed. Loadings and material properties. M25 grade of concrete and Fe500 grade of steel are used for all slabs and beams of the building, whereas M30 is used for columns with same grade of steel. Elastic material properties of these materials are taken as per is 456.2000. The short-term modulus of elasticity of concrete is taken as equals 5000 VMPa equals characteristic compressive strength of concrete cube for the steel rebar with stress, and modulus of elasticity is taken as per is 456.2000. While applying the loads to the structure, we consider only the external loads which are actually acting on the members, neglecting its self-weight, because ETABS 2018 and STAADPRO automatically take the member's self-weight. The seismic loads EQX and EQY are given in load patterns directly using code is 1893:2002. Also the wind loads WindX and WindYR is 875:2015 by ETABS 2018 given using code is 875:2015 by ETABS 2018. Elevation, top view, and 3D model of the building. 4 conclusions. Based on the response spectra study on multi-story regular building, following points are concluded. The dynamic analysis must be carried out for high-rise structure with vertical regularities having height more than 40 m. As the modal mass participating factor is more than 75% in the higher mode, the considered structure is stiff for earthquake excitation. Response spectrum analysis was performed on the building. From this analysis it was concluded that the structure has good resistance to smaller earthquake of moderate magnitude and intensity. The story displacement in x direction is found more as compared to y, and due to the fact that the earthquake motion was applied in x direction. By the analysis results, we can find that the base reactions for the structure is coming little bit different.